All right, guys, so I wanted to go over the questions for the review, just so that you could kind of have some help with review. But I encourage you to be writing as I'm writing, stop, rewind, whatever it is you need to do in order to get some understanding, do that. I imported these little reminders of the properties. Feel free to go back to February 2nd folder, and that's where these documents are. Feel free to print them out, download them, whatever you need to do. But this is strictly just for reviewing purposes. So what I'm doing is what I'm kind of trying to model for you what I think you should do as far as, working on these properties, okay? So here we go. All right, so the first problem here says simplify 3 to the 5th raised to the 2nd power. All right, notice here we have one base raised to an exponent, and all of that's being raised to the 2nd power. So that should remind us of this power of a power rule right here, because we have x to the n raised to the, x to the m raised to the n. And when we have that, what's happening is that m is being multiplied by n, and we have some examples here, right? We have some examples. So that's what we're going to do here. We're going to apply that rule. So this would become, let's see. Yes, all right. This would become 3 to the 5 times 2, right? Which is 3 to the 10. And we're done with that problem. All right, and now we're going to scroll on down to the next problem. I am going to be dragging and dropping my little worksheets with me as I go. All right, so the second problem, it says simplify, right? Now this big fraction bar is telling us that we're going to be dealing with division. Fraction is just division, right? So the only rule that deals with division is quotient, the quotient of powers. So we know that in this problem, we're probably going to be looking at this quotient of powers. So we need to make sure we have an understanding of it. Feel free, anytime that I go through something and I tell you the rule to use, feel free to pause the video, work it out, and then see if you come up with the same reasoning that I did. All right, so here we go. All right, so negative 27 divided by negative 6. Well, we know a negative divided by a negative is a positive. So when we have this negative 24 divided by negative 6, well, 4 times negative 6 gives us negative 24. So this is going to be a positive 4, right? Just like that. So this little part right here has already been taken care of. All right, now we need to focus on this w to the 6 divided by w to the 3. Remember, we're doing this quotient of powers. And when we have quotient of powers, same base, we subtract their exponents and write them as one base. So this will be w, but raised to the 6 minus 3. All right, and then now that we're done with the w's, now we're coming to the x. This x is raised to the 1 down here in the denominator. So this will become x. And remember, same base, so we subtract the exponents. So x to the 2 minus 1. Now we're done with the x's. We come to the y's. This y to the 3 minus 5, right? Because all we're applying is this quotient of powers. And then z to the 1 minus 4. So that when we simplify, we end up with 4w to the 3, because 6 minus 3 is 3, right? And then x, y to the negative 2, z to the negative 3. Now, we need to apply the negative exponent rule here. Negative exponents rule. All right, and what does that rule say? Well, if we have x to the negative m, we change it to 1 over x to the m, right? We already got a numerator here. So this would become 4w cubed x times 1 over y squared times 1 over z cubed. All right. And now we just need to be multiplying here. All right, so that this becomes 4w cubed x times 1 all over 1 times y squared times z cubed. All right, and this will basically give us 4w cubed x over y squared z cubed. You don't have to do it like that, but I wanted to make sure it was understood why this answer is the answer. All right, let's go to the next problem. All right, we'll try to move a little bit quicker. All right. So with this problem, it says a circle has a radius of 11x to the 5th, right? Radius 11x to the 5th, y to the 9th. The area of the circle can be found by using A equals pi r squared, right? Area equals pi r squared. What is the area of the circle in square centimeters? Well, we have to take our rule, A equals pi r squared, right? And take what we're given, which is the radius, and we're going to plug it in, just like that, in order that we find the area. All right, so that we might find the area, okay? Because this is what we want. This is what we have. And now it's just a matter of simplifying. All right, so this becomes pi times 11x to the 5th, y to the 9th, quantity squared, and then equals A. We distribute the 2 inside so that we have pi times 11 squared, x to the 5th quantity squared, and y to the 9th quantity squared, right? Now, I forgot to say what rule we're using here. But this rule is our power of a product. This rule right here says if we have a product, all right, there we go. If we have a product, then we distribute that exponent to what's inside, to each part of that product. So that's what we did here. All right, that's what we did here. We distributed the 2 inside the product, so we use this rule right there. All right, so we did that, and now we're going to apply power of a power, right? Because we have a power raised to a power. So x to the 5th raised to the 2. 5 times 2 is 10. So this becomes x to the 10. Y to the 9th raised to the 2. 9 times 2 is 18. 11 squared is 121. And whoop, there it is. All right, let's keep it moving. So with this next one, kind of bring this over here a bit. It says simplify x to the 5 times x to the negative 12. Note that we have the same base here, so we're actually going to use product of powers. This becomes x to the 5 minus 12, or plus negative 12 actually. Let's do it that way. All right, and so that this becomes x to the negative 7, but realize that we can use our negative exponents property that we learned about, and that says that if we have a negative exponent, we can write it 1 over x to the positive exponent. So this can be written as 1 over x to the positive 7. And there we are. All right, let's go to the next. All right, let's go to the next. So we have 20q to the 6, w to the 9 over 2w to the 4th, all of that jazz. All right. So I say take this one step at a time. We see this fraction bar. So that means we're going to be using the quotient, right, of powers. So we're going to be using the quotient of powers here. All right, and so let's get started. We're going to start with this one, and then we'll come to the second one. So 20 divided by 10, 20 divided by 2 is 10. All right, q to the 6 has nothing to go with, so it's just q to the 6. And w to the 9 over w to the 4. This little part here should definitely remind you of the quotient of powers, right? We have the same base, so we need to subtract our exponents. 9 minus 4. And of course, we know that's 5. And so now we're going to add in the 5 times q to the 6 raised to the 3 over w to the negative 3. Now, this right here, power raised to a power. So power of a power rule. We need to be multiplying there. So this here next line is going to be 10 q to the 6 w to the 5 times 5. 6 times 3 is 18. So this will be 5q to the 18. And of course, this is over w to the negative 3. But remember, when we're dealing with negatives, we can use, if there's a negative in the denominator, we just bring it up top so that it becomes positive. And so that's what we're going to do here. All right, so w to the negative 3 comes up top. All right, it comes up top. So we have 10q to the 6 w to the 5 times 5q to the 18th, and now w cubed. Now we're going to rearrange this. So that we have 50 q to the 24 w to the 8, and that's by product of powers. There we go.